and Assalamualaikum. Okay, so in this video I'm going to explain to you about regression, okay, which is in 4.2, the last part of your chapter 4. Okay, so regression will exist, okay, whenever there is a linear correlation exists between two variables. Okay, so how do you identify either something have a linear correlation? Okay, so if it's a linear correlation, you can determine it using a scatter diagram. Okay, so whenever linear correlation is present between two variables, then regression line is definitely present. Okay, so I have here three different scatter plot. Okay, so in my first scatter plot is a positive linear correlation. Okay, so in this positive linear correlation, as you can see, there is a one regression line in a positive gradient. Okay, my second scatter plot is a negative linear correlation, and since there is a correlation present, so there will be a regression line. Okay, so regression line in this time it have negative gradient, okay, because it's a negative linear correlation. And my third pictures, there is no correlation, so no regression line. So it's very simple. Whenever there is a linear correlation present between the two variables and you find it out in your scatter diagram, okay, so that means there will be a regression line. So the regression line is having a positive gradient, okay, or negative gradient depending on the types of correlation that is present. If it's a positive linear correlation, it's a positive gradient. If it's a negative linear correlation, it's a negative gradient. Okay, so linear regression, okay, it works best when we have a very strong correlation. Okay, strong correlation, that means it have high values of R values. Okay, so how do we find out either some things have a strong correlation or weak correlation? Based on R value. Okay, R values of, we have two types. First is Pearson correlation coefficient, okay, and the second type is from the Spearman rank coefficient. Okay, so this R value will determine either your variables have a strong correlation between each other or is a weak, and either is negative or positive. Okay, so whenever we have a linear correlation exists between the two variables, there will be a regression line, and this regression line we can determine the equations of the line, which known as equation of at least squares regression line. Okay, which is a linear equation in the forms of y equals to mx plus c, and m is its gradient and c is its y-intercept. Okay, so this is based on the basic of linear equation. But when you determine the types of least square regression line equation, you will need to have this different formula, but it still carry the same meaning. Okay, so if it's a least square regression line y on x, okay, so it will have y equals to a plus bx. Okay, so another one is a least square regression line of x on y, and the equation is x equals to c plus dy. It still works the same thing, okay, where your a should be your y-intercept, okay, and then your b is your gradient. Okay, for the first line y on x, when it is a regression line of x on y, so c is your y-intercept. Okay, so d is your gradient. Okay, how do I find this? By comparing it with y equals to mx plus c, the basic linear equation. Okay, okay, so there is a special formula to calculate constant. Okay, so we have constant b in our linear square regression line y on x. Okay, so b, okay, so how to find b? Okay, b is simply s prime xy over s prime xx. Okay, so what is s prime xy and s prime xx? Okay, so you have to refer or remember to your Pearson's correlation coefficient, where your s prime xy is simply and sum of xy minus sum of x multiplied with sum of y. Whereas your s prime xx is simply n sum of x square minus sum of x and square. Okay, so in regression line of y on x, we will find out this b. Okay, so next, how we going to find out what is a? So a can be calculated, okay, by using this formula. So since y equals to a plus bx, okay, so a is simply y minus bx. But this time, this y is actually mean of y and this x is mean of x. So mean of y is equals to sum of y divided by numbers of samples. Okay, and mean of x is equal to sum of x over number of samples. Okay, so you have to memorize this one. Okay, so which one do we going to use? If we're going to use this regression line of y on x, okay, we're going to use it when our given values is x variables. Okay, you have controlled the x variable, you have fixed the values. Okay, so you're going to find out what is the values of the y variable. So y, name it as dependent variables because it depends on the values of x. Okay, secondly, okay, so least square regression line of x on y. Okay, so if we have constant b for line y on x, we have constant d, okay, for line x on y. Okay, so the difference is just the denominator. Okay, so in b, we divide s prime xy with x prime xx. We divide s prime xy with s prime yy. Okay, so s prime yy is simply equals to n sum of y square minus sum of y and square. So this is the formula, exactly the same like you did in your Pearson correlation coefficient. Okay, so how are you going to determine c? Exactly the same way as you determine your a. Okay, so x equals to c plus dy. This is the given equation. Okay, so we're going to rearrange to find c. So c equals to x minus dy. And again, this x should be mean x and this y should be mean y. Okay, so x equals to sum of x over n and mean y equals to sum of y over n. Okay, so when you're going to use this regression line x on y, that means you have set your variables y as the control variables. That means you already set all the values that you're going to study for the y variables, and the values of x, we name it as dependent variables because it depends on the values of y for the x values. Okay, right, so this least square of regression can be used to predict unknown values for the dependent variables based on the given independent variables. That means, for example, if we have line y on x where x is the independent variable, okay, so we can find out what is the y values based on this. Okay, y values, what is it? So we can find out, okay, based on the equation. Okay, so before we predict what is the value, okay, before we want to use it for prediction, that means we need to determine what is your equation first. Okay, let's try with first example. Okay, so find the least square regression line of y on x for the data in the given table below. Okay, so you'll usually given with data for your x and data for your y. Okay, then as usual, you need to tabulate the data, okay, to find the constant. Okay, so since this is line of y on x, that means you have to find out the equation for y equals to a plus bx, where your b is s prime xy over s prime xx. Okay, so to find out s prime xy, s prime xx, that means you need to find out, okay, so what is x squared, then what is xy. Okay, and so we have x equals to 10, 20, 40, 60, 70 and 80. Okay, so the square of x is simply 10 square, which equals to 100. Okay, then 20 square equals to 400. Okay, 40 square equals to 1600. Okay, 60 square is simply equals to 3600. Okay, 70 square equals to 4900. 80 square equals to 6400. Okay, so what about xy? So xy is just simply your x multiplied with y. So 250. Okay, so 250. Secondly is 720. Thirdly is 1920. 3540. 4550. 5520. Okay, so next we need to find out what is the sum of all of this. Okay, so sum of x, sum of y. Okay, so the sum of x is just simply you add up all the values of x, which is equivalent to 280. Sum of y, just simply add up all the y values and it equals to 302. Okay, so sum of x squared is 17,000 and sum of xy is equals to 16,500. Okay, so based on this given value, then we can find out our constant b first. Okay, so your b is s prime xy over s prime xx. So find out first your s prime xy. So s prime xy equals to n sum of xy minus sum of x multiplied with sum of y. So we have here 1, 2, 3, 4, 5, 6, 6 data. So your n is 6. Sum of xy is 16,500. Okay, minus 280 multiplied with 302. Okay. Which is equivalent to negative 102,600. Okay, please make sure you include the sign. Okay, next we have s prime xx equals to n sum of x squared minus sum of x squared. So 6 for the n numbers, and then your sum of x squared is 17,000. Okay, minus your x, which is 280 n squared. Okay, so this time it equivalent to 23600. Okay, so we can find out your b. So b is a constant. It can be a positive or it can be a negative. So substitute the values that you already calculated before. Okay, then press your calculator to get the final answer of your b. Okay, which is negative 4.347. So leave it to 3 significant figures or 3 decimal places. Or okay, so next, when you have your b, you can find out what is your a. Okay, so y equals to a plus bx. Okay, so your a is y minus bx, and this y is the mean and this x is the mean. So y mean is simply sum of y, which is 302, divided by the numbers of sample, which is 6. Okay, minus, so we have here negative 4.347 for our b, and sum of x, mean of x is sum of x. Okay, which is 280 divided by the total number of sample. Okay, so your a is exactly like your b constant. It can be positive or it can be negative. Okay, so you need to find out. So whatever the sign that appears, you need to ensure, okay, you take it out, take note of it. Okay, 253.20. So let's rewrite. So your equation of regression line, okay, is y equals to your a 253.20. Okay, so b should be plus, but since your b is negative, so minus 4.347x. Okay, so from these values, from this calculated equation, line, okay, you will later can predict what is the y values from the given values of x. Okay, so let's move on to the second example. Okay, so here again we have x and y, but this time we need to find out line x on y. So it's c plus dy equals to x. Okay, and your d is s prime xy over s prime yy. Okay, so first we need to fill out the table with the values of y square and then xy. Okay, so please feel free to pause the video first while you try to calculate the values of y square and xy. Okay, so after you calculate all of these values, you need to find out the sum of your x, okay, and then sum of your y, and then okay, so we have here y square, so sum of y square as well, okay, and lastly sum of your xy. Okay, so the best is to leave it up to 3 decimal places. Okay, so next, okay, to find your constant d, that means you need to find out what is your s prime xy. So s prime xy is again n sum of xy minus sum of x multiplied with sum of y. Okay, so then substitute the value. So we have here 1, 2, 3, 4, 5, 6, 7. So 7 data in this time, so your n is 7. Okay, 6.166 is your sum of xy minus sum of x, which is 0.98, multiplied with sum of y, which is 44.2. Okay, so which this one equals to negative 0.154. Okay, so next, okay, so in your d you have s prime yy instead of s prime xx. So it's just the same, but it's now n sum of y square, okay, minus with sum of y and then square. So n is again 7279.28, okay, minus 44.2 square. So it's equivalent to 1.32. Okay, then we can find out our d. So d equals to s prime xy over s prime y. Okay, so your s prime xy is 0 minus 0.154, okay, over 1.32. Okay, then press your calculator to find out what is your d values, which is negative 0.117. Okay, then we're going to find out what is our c. Okay, so x equals to c plus dy. Okay, so your c is simply x minus dy, and this is mean x and this is mean y. So mean x is sum of x divided by the number of sample, which is 7, okay, minus, okay, your d is negative. Okay, then your mean y is sum of y divided by the numbers of sample that is present, okay, which is our sample, we have 7. Okay, so your c can be a positive values or it could be a negative values. Okay, so it depends, but please take note of the sign. If it's negative, then put it as negative. Okay, and this time I got it as 0.879. Okay, so let's write down the equation. So x equals to c plus dy. Okay, so your c is 0.879 plus your d is negative 0.117 y. Okay, so rewrite it again. Okay, because I want to eliminate that bracket. Okay, so that is the final answer. So that is your line, regression line. Okay, least square regression line of x on y. Okay, so let's look at the harder examples which involve a more difficult questions involving wordings question. Okay, so a study is done on the yield of a plant and the amount of fertilizer used per week. So the results for 7 plants, okay, so this is your n, 7, chosen at randoms are shown in the table below. So you have x and y. Okay, so find the least square regression line of mass on amount per week. Okay, so your mass, okay, so your mass is y, and then amount per week is your x. So that means line of y on x. So you have to find out what is y equals to a plus bx. Okay, so in order to find your b, you need to use, okay, so b equals to s prime xy over s prime xx. So we need to tabulate the data, find out what is x squared and what is xy. So I already calculate the values of my x squared for all of my data, and then for my xy, and already calculate what is your sum of x, sum of y, sum of x squared, and sum of xy. That means I'm ready to answer question A. Okay, so is the least square regression line of mass on amount per week, so y on x. That means I have to find out, okay, y equals to a plus bx, and my b is, okay, so my b equals to s prime xy over s prime xx. So first need to find out what is s prime xy. Okay, so n sum of xy minus sum of x multiplied with sum of y. Okay, so 7 samples, so sum of xy is 1590.48, okay, minus sum of x 210 multiplied with 49.56. Okay, that one is equivalent to 725.76. Okay, then s prime xx, okay, so n sum of x square minus sum of x, we square it, so 77308 minus 210 square. Okay, okay, which is equivalent to 7056. Okay, then I'm going to substitute it into my b formulas to get the values. Okay, so equals to 725.76 divided by 7056. Okay, so your b values will be a positive numbers. Why? Because our s prime xy is positive, so 0.103. Okay, next we're going to find out what is our a. So a equals to y mean minus bx. Okay, then your mean y is simply sum of your y, okay, which is 49.56, okay, divided by 7, okay, number of sample, minus your b 0.103, okay, and then your mean x is sum of your x divided by the number of sample. Okay, okay, so your a, I got it as 3.99, so it's a positive number. Okay, so let's write down the equation. Okay, so y equals to a plus bx. Okay, so I'm going to substitute my a is 3.99, okay, plus b is 0.103x. So that is the values. Okay, so that is the regression line of mass on amount per week. Okay, so now we already have the least square regression line. We can move on to question B. Okay, so in question B, okay, it asks you to predict the values of y when 44 grams of fertilizer is used. Okay, so amount of fertilizers is your x. Okay, so that means we have to find out what is your y. So at x equals to 44, okay, so y equals to 3.99 plus 0.103. So we use the regression line, okay, to predict the values of y, and then substitute x with the given values of your x. Okay, so your given values of x is 44. So substitute the equation, you will get it to be 8.522 in a gram. Okay, next, estimate the yield of plant when 60 grams of fertilizers is used per week. Okay, so that means now it is at x equals to 60. So we're going to do the same thing. Okay, use the regression line to find out what is the y value when your x equals to 60. Okay, so this time is equals to 10.17 gram. Okay, so D, what is the yield of plant if no fertilizers is used per week? Okay, so if it's no fertilizers used per week, that means you're at x equals to 0. So your y becomes 3.99 plus 0.1030, so equals to 3.99 gram. Okay, just a little comment here. Okay, if you're referring to the recorded values of fertilizers we use, is from 12 until 48. Okay, and it's valid if we calculate the y values for x equals to 44. Okay, and then for x equals to 60 and x equals to 0, okay, for your question C and D, is a little bit out of range from the recorded values of amount of fertilizers used. So this C and D is just simply an estimation. Okay, it could be right or it could be wrong, because we are not sure. Either there is still a linear correlation present at x equal to 0 and x equals to 60. Why that so? Because 60 and x equal to 0 is out of range from our recorded values of x. Okay, so that is just a little comment. Okay, if they ask you to comment either what we get for your y values for question C and D is valid or reliable or not, but if question B is reliable, okay, it's because 44 is still within the range of our recorded value. Okay, so E, explain why the regression line of y on x is computed. Okay, what does it mean with computed? It means why do we calculate regression line of y on x instead of line of x on y, okay, and not the regression of line x on y. Okay, why do you think so? Because, okay, like the first first page that I introduced to you, so there are two types of regression line. One is y on x and another one is x on y. Okay, so which one we're going to use? It depends on which variable is set as your independent variables. Okay, so independent variables, that means the variables that has been controlled. We set the values. Okay, so this independent variable, we set the values, we control the values. Okay, so in this time, we control the values of x because we already said. Okay, so let's say the first one, we try with 12 amount of fertilizers per week. So what will happen to the mass of product? Okay, then we try what will happen if we use 18 amount of fertilizers per week, and what will you see to the amount of mass produced. Okay, next we fix it to 24. Okay, so that means your x is the fixed variables, okay, or control variable. So this one is the independent variable. So that means mass of y is entirely depends on the x value. So this is dependent variable. Okay, so therefore it's correct for us to determine regression line of y on x, because the control variables, the fixed values or the control values is your x. You already set x values to certain specific numbers of values. So we study what will happen to y based on the x value. So that's why its logic is valid to find regression line of y on x instead of regression of line of x on y. So how do we write down it in the sentences? Okay, so questions E. Okay, we determine, okay, least square regression line, least square, okay, regression line of y on x, because we fix the values of x, means x is the independent variable and y is the dependent variable. Okay, we cannot determine, Okay, least square regression line of x on y for this case. Okay, because y values are not being controlled. Okay, so that is okay. So I hope you have now a clear understandings on how to determine your least square regression line. Okay, and which least square regression line that we're going to use? Is it y on x or x on y? Again, you need to determine which line based on the given which one is the control variable. Is it the x or is it y? Okay, so it is advisable, okay, if you are not sure, if the question don't ask you which line is this, okay, so refer to the next question if there is a prediction question. Okay, so thank you for watching. Okay, bye bye.